Hello viewers, in this video we will go through Cambridge A-Level Further Maths Component 1, which is Further Pure 1. This is Variant 1 from the May June 2025 series. So I noticed Variant 1 and Variant 2 from each series is the same. So it's Variant 1, 1 and 1 2, that will be the same paper. So this apply for same as the Variant 2 paper. And this video will go through question 1. The upload have been a bit slower because I've been busy with other stuff. So the upload a bit slower lah, okay. Question 1, use the standard result from the MF19 to show this summation can be written as a polynomial in terms of n. The standard result they are telling us to use is this one lah. So basically, if you have a sum of r, or r equals 1 to n, you can rewrite it as this type of quadratic equation. And if you have r squared, then it will be a polynomial in terms of the third order lah. So I mean the proof, you can go and find the proof. I'm not going to demonstrate the proof here in this video. It will be quite long, I think. So what we're going to do is we'll expand the brackets inside the summation first. Now we have already written as quadratic in terms of r. Then each one of it, so r squared, we can replace it with this. Okay, and then r, we can replace it with this one. What about the 10? Okay, sum of, let's say you have in the equation you have just the 10 left over there. So you sum every time it compounds. So it's, let's say you have 1 to 2 lah. Your sum of r equals to 1 to 2, but the 10 is just there. So you sum 2 times, you get 2 times 10. Okay, so if summing n times, you just get 10n. And since the summation is the operation is linear, we can just add each other, or add everything together. So I'll go ahead and add the r square first. Okay, after the simplification, make sure that, after the substitution from this step onwards, it's just about your algebra, it's about you expanding the brackets. Make sure you do it carefully, don't make any careless mistakes. Otherwise, it's 3 marks gone, right? It's just 3 marks here. But anyway, yeah, the steps of this is not hard, it's just about computation. Okay, now we move on to part B. Part B is asking you to use the method of differences to find this summation in terms of n. Method of differences, what they teach you is probably something like, if you have a function inside here, we can represent it as maybe fx minus gx, maybe, or like, if you have a function inside the sum, then we can represent it as a difference. So if we take something like f1 minus g1, then we sum it lah. We sum it basically from x equals to 1 to n. So we can represent the function like that, minus g2, and so on and so forth, right? Until we get to f n minus 1, g n minus 1, and lastly is fn minus g of n. And why we do this is because we hope that something that will cancel, maybe is f1 and f2, f1 and maybe g2, something like that will cancel, and then f2 and g3, and so on and so forth, right? So that's the method of differences. In this case, how we make it into two different functions, okay, you can see is a rational function with two first order what we call as roots on the bottom, first order factors lah, basically. So we can use the partial fraction method. So I hope you have learned already this one. If we have a rational function like this, we can rewrite it as a partial fraction of a constant on top, and then the first factor on the bottom, and then another factor on the bottom. So linear factor, we don't have to add r on top. If it's let's say it's second order factor, we have to add another term, and so on and so forth. But it's a first order, so linear term, so we don't have to add anything. So what we're going to do is we multiply both sides of the equation by this one, the both of the denominator, or both of the factors, and then on the left hand side we'll just get 1, the right hand side you reduce to this type of expression. And now we choose r. Okay, we choose different value of r so that we can eliminate each one of these term to find the constant. So let's say we choose r to be 5/3 first. So if we choose that, the first, I mean the coefficient of a will go to 0, right? Because 3 times r is negative 3 times r is 5, negative 5, 5 minus 5 0, so we just get b equals to 1 over negative 3. Okay, that's r 5/3. Now we go for, to eliminate the b coefficient, we go for 2/3, which you get a as 1/3. With this, you have able to found or represent the summation just now, like that. Yeah, we have simplified the summation just now to, or not simplified, but we have made it into a difference of two functions. And I'll go ahead and simplify it even further so that this fact, what we call as a multiple of 1/3, you can take it out of the summation. So yeah, it's easier to deal with like that. And make sure that the coefficient a and b, you don't mix it up. If you mix it up, then they will cause you some problem. Okay, now what we're going to do is we are going to one by one we substitute the values of r equals to 1, r equals to 2, r equals to 3, and so on and so forth until we see a pattern, right? Okay, now we written out the case where r is 1 to 4, and in between we leave dot 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 because there's still a lot in between. And then also I write out the last two terms for you to see. So I mean, if you are more if you know how to do this already, you able to save some time by not writing so many. But I'll just show you and see first. So you try and notice some pattern here. This is a method of differences, so there will be some pattern showing up that something will definitely cancel. So you can see a 1, negative 1, that 2 cancel, right? And you also can see that 1/4, negative 1/4, 1/4, they cancel. And this continue, right? So the first one and then the last one, it will cancel out. Okay? And we repeat the pattern. So this one is going to be cancelled out by some term, the term in front. And then this 1/5 minus 3n, and this 1/5 minus 3n, these two cancel out. So and this negative 1/10, it will be cancelled out by the following term in front somewhere. Okay, so what we're left with, okay, if you have done the cancelling carefully, you just have I missed out this one also. The 1/3 is still in front, everything, okay, the whole thing. So the multiple, don't forget it. 1/3. So you have a 1/3 in front, and then you're left with just this one, 1/2, and then this one, 1/2 minus 3n. So I make sure this one cancel also So we're just left with negative 1/2 minus 2 minus 3n. So then we can just multiply this 1/3 in, and that's it. Okay, so this is the final answer for the summation. So the entire summation, it will end up to be this. Now, if we go to part C, we want to deduce this value. So it's just by saying that just now we have the sum of 1 to n, right? So I'm just gonna write it as the same just now what we have. And then we gotten this result, 1/6, 1 minus 9, 6, and 6 minus 9, sorry. Okay, so this is the result that we have. So now we just want to change the value of n where it goes to a very big number, which is infinity. Or I mean, it's a very big concept. So the official or the more correct way to do this is you take the limit as n goes to infinity, and we take it on both sides. Okay, but I mean, obviously for Cambridge, I think they teach you just as a informal limit where n goes to infinity. This term, right? Because this term, the denominator where n gets larger, the denominator gets even larger, so the value of this goes to 0. But this term, negative 1 over 6, remains unaffected because there's no n there basically. It's just a constant value. So this term goes to, I mean, it approaches 0 as n approaches infinity. So this value, it will tend to negative 1 over 6. So it's just left 1 over 6. I'm a negative 1 over 6, right? So that's the final answer for part C. And yeah, that's the question 1 for this paper. Okay, thanks for watching.